And we're live. Cool. Yeah, seems to this thing is working, I think. Hey, well, welcome everyone. Thanks for joining to our March event today. We are the Charlotte Java User Group, and in case you want to know more about us, or if you're interested, getting some feedback. Sorry. Okay, let me. Yeah, I was watching our own stream. Yeah, so if you want to know more about us, you can find us in these places. We're always looking for to get more people to join our group. We're always looking for sponsors, speakers, or anyone that just want to say hi. These are all the places where you can find us. And we want to welcome our friends from the Virtual Java User Group North America. We have the pleasure of hosting the event this month, so we appreciate everyone that is coming from the Virtual Java User Group. In case you, right now we are all online, right? So we're doing these meetings in a virtual mode. So feel free to join our Charlotte Java User Group as well on Meetup. And if you know, especially if you are from the area or you know someone from the area, let them know that we're here. But we want to welcome everyone and that we're really happy to host on hosting today's event. Yeah, I want to talk about. We're creating this new initiative, Abel and myself. We're creating this other group. We're calling Devs Office Hours, and the goal of this group is just to have an informal discussion. I mean, a group of technologists just sharing knowledge and learning from others. Basically, what we're trying to do is something that if you are having you are trying to solve a complex problem at work and you want to hear a second opinion or a third opinion, or you're new to the industry, new to Java, new to any technology, and you want to just ask questions and you want to talk about professional career development, anything that you need some help, or if you feel like you can mentor people, I mean, you can also join just to see if you can help anyone else. Uh, so this is an open group for anyone at any level. So we're trying to make this just to have a informal discussion and try to help anyone that have any questions or any challenges at work. We still, I mean, we're planning our first meetup on this. But if you are interested in sharing, if you're interested in learning from others, feel free to join. And again, we're going to do this virtually right now. And we'll see what happens. And finally, stay for the raffle. Our sponsor, JetBrains, provide us with licenses for their products. So stay tuned. Pay attention to the session. Roberto will make a couple of questions at the end, and if you get it right, if you answer quickly on the YouTube live chat, you can get a 1-year license for a JetBrains product. So I think that's pretty cool. Talking about YouTube Live, we have a small delay when we're streaming. I mean, just a few seconds. But if you have any questions during the talk, feel free to post it on the live chat, and we'll be monitoring that, and we'll find a good time to interrupt Roberto and ask the question. I also want to thank, of course, our speaker today. We're honored to have Roberto here with a really, really interesting topic. So without further ado, Roberto, I'll let you introduce yourself and take it away.
All right. Awesome. Thanks, folks. Let me just share my screen and then we can start. All right. So, can you see my screen now? I'll take it as a yes. All right. Hello, everyone. I'm really excited to be here today to talk to you about how we leverage Gradle at Netflix. This is a talk that I gave in the past probably a couple times already in Spanish for our user group in Mexico and Spain. So I'm really excited to have the opportunity to reach a bigger audience now via this Charlotte user group. So thanks, Orlando and Abel, for giving me the opportunity to talk to you today. So before jumping into the topic, I'd like to introduce myself. So I'm Roberto Perez. Right now, I'm working as a senior software engineer at Netflix as part of the Java platform. And the Java platform is basically a team that provides opinions for the build side of things and also for the frameworks for the JVM platform at Netflix. Here are the links for my email, my Twitter account. Feel free to reach out if you have any questions, if you want to chat about technology, sports, whatever. I'm always happy to meet new people and meet new engineers and having fun. Hopefully someday we'll get to know each other in person in a conference or another one of these kind of events. So to start, I would like to talk a little bit about the context of what does it mean to build JVM applications or libraries at Netflix. So many years ago, Netflix was a monolith written in Java with Tomcat. And at some point in time, probably 9 years ago, the engineers at that time decided that they wanted to start exploring new architectures in order to scale better. And this is how they came to start using microservices architectures. And one of the big decisions around that time was, okay, if we are going to build all these services that will be living in their own repository, because they decided to also do multi-repo and not a mono-repo approach, was like, okay, if I have a service, I'm just going to build a fat client that is going to be shipped with this service. So basically, every time that you are at Netflix as an engineer and you create a Java application, you will also be bootstrapping a jar file that you can distribute to your customers and they can start using to call your service. 10 years after, this became a huge ecosystem. We have around 3,000 repositories that use Nebula, Gradle. And as you can see on the right side, this is probably a dependency graph for one of our biggest projects. Have hundreds of thousands of dependencies. And as you can imagine, because we have multiple repos and thousands of jars that get distributed across Netflix, we have to integrate binaries every single day, which is a difficult task. And we have hundreds of engineers. These engineers are working in multiple languages: Java, Groovy, Scala, Kotlin, Clojure. So we have covered around multiple languages on the JVM. Prior to use Gradle, Netflix was IB and shop. And they decided to jump into Gradle because at that time, probably 7 years ago, Gradle was quite new. It was probably on early stages, and it was really promising. It seemed like the modern tool to use. And instead of going to the natural replacement from Ivy to go to Maven, they decided to just jump into the Gradle ship. And well, here we are today. So in terms of builds, this is an estimate of builds in the last 15 days. We have around 300,000 builds, so that makes 150,000 every single week. And this gets translated into more than 900 days that are spent on building things at Netflix. And this is only for Java projects. And this ends up in how many artifacts we produce every day. So every day, engineers will just go and make a change to their code. They will trigger either a Jenkins job or a Spinnaker pipeline. And what they will get is the jar for the client or for the library or for anything else that they develop in the Java platform. And we produce around 9,000 artifacts every single day. And this is between snapshots, release candidates, and final releases. But at the end, as you can see, this is an environment that evolves very quickly. Every single day, you might be an engineer that is writing against my client version 1, and the very next day, you might be on version 3. So it's really dynamic and difficult to manage at some point. And this led Netflix to take a huge decision on how do we leverage all these changes. So we decided that we will go and ask everyone to always be using latest release of a given library. This way, every time there's a new release, they will pick up the change, and they don't have to go and manage versions themselves. So with that context on the scale on the build side of things at Netflix for the JVM, I would like to talk a little bit about the problems and challenges that we face every single day. Yep, we have challenges. So the biggest one, or the classic one, is broken build. So as an engineer, I can go home after a full day of work. My project is building, is working properly, and then overnight something happened. I come to the office the day after that, and I see that my Jenkins job is in red. I didn't change anything. What's going on? And I'm always using latest release, right? So it's probable that something changed in the dependencies, but as a developer, I don't really have the context of what changed. So this happens when somebody adds a new dependency or the dependency is upgraded. And this is not only directly, it can be via transitive dependencies in your build. In addition, it's quite common to have dependencies that are not aligned anymore. So for example, you might have a family of common modules like Jackson. And when you use Jackson, you have things like Jackson Core, Jackson Databind. You have specific modules for things like JSON and so on. And if those versions get skewed and you don't have the same version for all of them, it is possible that at some point they won't work correctly. So it is important to make sure that they are aligned. Another classic example of broken builds is bugs. As I said, we run with latest release always, so it is quite possible or highly probable that at some point your project is going to get a bug or even a security vulnerability coming from a transitive dependency or just from the clients that you are using. So it is important that we provide leverage for users so they can understand what's happening with this. And another one that it's really specific to Gradle is my Gradle plugin is not compatible anymore. So what happens if you decide to upgrade your Gradle wrapper version? And then you are using some random plugin that you found in the Gradle plugin portal, and that plugin is not compatible with the version of Gradle that you're using anymore. So this is quite common, and this is one of the pain points that we see, not every single day, but it's common to see at least once a week, every 2 weeks or so. Another one of the pain points from users that we are usually looking into better ways or to enhance the resolution time is slow builds. Basically, the things that happen here are dependency resolution. Basically, you have a project that you can have multiple dependencies. There will be transitive dependencies. It might take a few seconds or more to resolve all the dependencies, but as times go by and you start adding more things, more dependencies, more code, this dependency resolution time can go higher. And in reality, you want to have only the things that you use. So it is important that you have a good hygiene in terms of like what are the things that you are asking for and that you really need in order to build properly. Another impactful thing in a bad way for slow builds are plugins that are doing bad things in the ecosystem. So for example, in Gradle, we have the configuration phase. And during this phase, basically Gradle is gonna understand the project, create a task graph of the tasks that should be executed, and then also configure all the objects that will be used for that execution. What could happen on plugins or custom tasks is that they could be doing things on configuration time that are not meant to be. For example, resolving dependencies or creating tasks that shouldn't be created because they won't be usable. So it is important that people that are building plugins explore things like lazy APIs and make sure that they are not eagerly resolving configurations here, because at the end, you are just hurting the performance of everyone in your company. Another common problem with the slow builds, and this was really interesting to find, is exclusion rules. As you can see on the right side, I have a small snippet of code where basically I can say in Gradle, you know what, for all the configurations, which configurations will be things like compile class path, test compile class path, runtime class path, and so on. I can go and exclude all these login frameworks because I only want to use a specific one. But if something else is on the class path, there might be problems in runtime where I can be filling the disk with bad logging and then taking down my service. So it is easy to go and say, okay, let's do this. Let's exclude this. But what will happen under the hood is Gradle is going to register an exclusion rule for every single dependency on every single configuration. And this is a huge performance hit. For example, on the project that I showed before on the dependency graph with thousands of dependencies, That project in particular, at some point, was taking around 35 minutes just to resolve dependencies. And after we held them to clean up a little bit these exclusion rules, they were down to less than 15 minutes. So it is really important that you revisit these opinions. Another important thing that I would like to express here is that for us, or at least for me personally, every time you add this kind of opinions, like exclusion rules or pinning to a specific version of a dependency, it's really tech debt. Because today, it might make sense to exclude it because it's in the graph. But maybe 2 years from now, that dependency either doesn't even exist in Maven Central, or it's not even part of the dependency graph at your company, and you're just hurting the performance of everyone else by adding these rules. So when you provide opinions like this, it is also important that you come back in the future and start cleaning them up. And another important one is lack of parallelization. If you're not aware, Gradle has ways to do parallel builds. By parallel builds, I mean you have two things. One is you can, if you had a multi-module project, you can execute all the modules in parallel. And this is quite easy to enable via a feature flag. And the second one, you can also parallelize test. You can go and tell Gradle that, you know what, for this test, I want to execute them in parallel using this number of threads based on my, I don't know, my cores in my infrastructure. And also I want to fork a JVM every once in a while and so on. So it is important that you take a look at this, take a look at the opportunities so you can parallelize your build. In addition, it's not as simple as just enable this, right? Because as you can imagine, it's not the same resources that you will have locally versus the resources that you will have in a remote environment like your CI, for example, Jenkins or Drone CI, whatever you use for CI infrastructure. So probably locally, I might have 8 cores, 16 cores, I don't know. And I might be able to create a lot of threads and run tests in parallel and so on. But then on CI, I might be more limited. And in addition, if my CI environment is shared, for example, on Jenkins, you can have multiple executors in the same Jenkins agent. So that means you will have multiple Gradle builds at the same time. Now you have these builds competing for resources. So it is important to take a look at these too. And also things like memory. So what happens if you go and say, you know what, Gradle, I want to use 3 gigs of RAM for my memory in test, and then the box that I'm running only has 2 gigs. So you will overflow the memory and everything is going to look terrible. So when you use parallelization, I think the advice would be really look into how your infrastructure looks like and then configure based on that. It's not really like just enable something and that's pretty much it. Another important problem that we see every day, and not only internally but also externally, is metadata. But metadata, I mean like module metadata. Either if you use Ivy or Maven or now Gradle module metadata, there might be cases where in your project you use dynamic dependencies. For example, in this case, I have something like persistence API that I want to use 2.x, or I want to use always the latest release of Guava. And this gets translated automatically to the POM file or the Ivy file with those opinions. And what happens is, as a consumer of this library, my result won't be the same every single time. Today, I might get Guava 19, and 2 months from now, I might get Guava 20, because the latest release opinion change over time. There are new releases of the software. So in Ivy and Maven world, we really try to avoid these kind of cases. We provide opinions for engineers in order that they always publish manifests or metadata that contains result versions, for example. And another important thing is we have seen metadata, but metadata coming from shaded libraries. And for example, in Gradle, you can use the shadow plugin. And the shadow plugin allows you to basically say, you know what, I want to create a shaded jar or a fat jar that will take, for example, in this case, Guava. It will take all the code from Guava and relocate it to another package. So instead of going to com.google.guava, it will be something like netflix.com.google.guava. And this way, my consumers won't have any issues with conflict resolution in the future. Basically, I'm just creating this massive jar with all the code in there. But people sometimes forget to remove those dependencies from the POM file. So at the end, you are not solving the problem. You are probably incrementing it, because now you are shipping a massive jar file, that has all the code that you need, and it's going to work, that's fine. But also you are providing an opinion of a dependency for your consumers that they don't even need. And you might be probably upgrading their project to a newer version of Java in this case, just because you forgot to remove that from the POM file. So these are the kind of things that we try to abstract away from users, and also the plugin does a great job on that, but something that we try to tell engineers to keep in mind every time they produce a new library or add a new thing to the shaded jars. So it is quite common to talk about reproducible builds. For us, it's just three things. One is being able to create a build on any given time for the same commit using the same binary dependencies. So if today I build my project against Java 19, if I go back to this commit 6 months from now, I should be able to build it against Java 19, and that's pretty much it. I shouldn't be building against something else. File ordering is important for us, and also we avoid preserving timestamps. Having timestamps inside your manifest and things like that make the builds not reproducible anymore, because at the end your jar will be different. The content of those manifests make the jar to be unique, basically. And another great huge pain that I have seen not only at Netflix but other companies is packaging. By packaging, I mean when I'm an engineer and my work is to build an application for, let's say, finance, the last thing I want to spend time on is how do I package this application in a way that I can deploy this to the cloud. These are exciting tasks. Don't get me wrong. As an engineer, I really love to understand what's happening. But the reality is that we want to boost your productivity as a centralized team. So in this case, what we try to do is provide engineers with proper infrastructure so they don't need to care about producing all of this. For example, in our case, we provide a plugin that allows engineers to create a Debian file that they can put in a AMI for AWS and then run that on a VM on EC2. Or similarly, we create a Docker file for them out of the box so they can just run that Docker image on Tidus. Tidus is our container orchestration platform built on top of Kubernetes. So basically, they don't need to know all the weeds about, okay, how do I construct a Debian file? How do I put this on a AMI? So we provide all that leverage for them. And this is a good one, the plugin ecosystem. The first thing that I want to say about the Gradle plugin ecosystem is that it's so big and so good. Like if you can think of a task that you want to do with Gradle in terms of like a build or automation, you can go to the plugin portal and you will find something for sure. And not only one option, you will find multiple options. It comes with a price, right? When you are consuming plugins, well, there are things like I mentioned before, Gradle compatibility. At some point, I have seen many projects that either the maintainer doesn't have time or decide to abandon the project, so they don't get upgrades anymore. There is no compatibility upgrades. And we ended up like either forking the project or writing our own. And that's something that really slows you down in your developing process. So just be aware that looking for plugins is easy, but finding the right ones is sometimes difficult. So try to find plugins that are well maintained, that you know that there are more than one person involved in this, so there might be someone that will take over the work at some point. Or if it is really important for your machinery, join the team, join the effort. Like doing open source is something that I wouldn't say it's easy, but also it's kind of a gift, I guess. Not everyone has the chance to get paid to do open source, or not everyone has the chance to have free time to do open source. But if you get the chance to contribute back to the things that makes you or makes your company to make money, that helps you to make money, you should probably spend some time helping the community to basically foster this nice ecosystem. Another problem with the plugin ecosystem might be strong opinions. Being a plugin developer can be hard. For example, what if I write a plugin that forces dependencies? Now I'm basically providing opinions to everyone that uses my plugin, and I'm forcing them to use a particular version of something that might break their project. Or what I said before, what if I'm creating tasks eagerly and I'm not taking care of the performance things? So like every open source things, right? You don't go and add things into your project right away. You try to get a sense of what's happening under the hood, or at least it's recommended that you understand what's happening under the hood and how this impacts your build. And yeah, upgrading these plugins can be a difficult task if you use the plugin blocks to say, I want to use, for example, Nebula made and published 17.3.2, which is on the right side. At some point, there might be a version 19 or 20. How do I keep up to date with these things? So that's really important. And this goes in hand with the fast evolution of Gradle. So Gradle is a great tool, and if you haven't noticed, there is a major release every year. There are minor releases probably every 6 weeks or so. But that also means that at some point they start introducing deprecated APIs, and you need to migrate to use the new opinions or the new recommendations. So how can you go and do this for everyone in your company or just in your projects? Like once you have more than 5 projects, I will say, it's becoming difficult, right? You need to visit every single project, look at the things that change, and what should you do, and hopefully you are not far behind the things in order that you can do a smooth migration. And this is not only about the DSL, right? This is also about the plugin authors, how the plugin authors start adopting new features of Gradle, because you might have control on your build, but you might not have control of the plugins that you're using. Quite common will be like plugins that don't have proper annotations on their task. Those things will break at some point. So making sure that you are not using deprecated APIs, making sure that you are using plugins that are not using deprecated things, it's a difficult thing to do. And obviously, when you work at exascale, like let's say 100 projects, 1,000 projects, you name it, introducing new features and keep up with Gradle releases might be difficult. You need to start prioritizing what are the things that you can do and when can you do them. And it's not. And for me, every build is unique, right? There might be 20 Spring Boot applications in your company, but every single one of those applications are unique, and they might have different requirements in terms of build, different dependencies, different ways that they configure something. So when this happens, introducing new features might not be as easy as just enable them. And one of the big things that I haven't seen really a solution on the open source is really the visibility. We lack publisher visibility. And what I mean by this is, if I own a library, either internally or open source in my company, how do I know who is using it? You may have things like download the statistics, things like that, but it doesn't tell you anything about how your library is used to. How do I know if I modify a method, if I modify my API? Is this going to break someone or not? So really understanding who consumes your library is probably one of the biggest problems right now that I will say that someone could face in software engineering when it comes to writing libraries. So what can we do about this? Certainly, we are not going to call the money haste people and try to fix this, right? We need to write some software that kind of helps reduce the pain. It is important to mention that things like dependency hell will always be there. You will always get into trouble. It's just a matter of writing tools or writing infrastructure that will allow you to reduce that pain and make the life of engineers better. So for that, we created Nebula. Nebula was created years ago. So what is Nebula? Nebula is basically 2 things. One is a set of Gradle plugins, and this set of Gradle plugins allows Netflix engineers to basically reduce the boilerplate in the build logic on their build files, and also provide all the same conventions that we think every single project in the JVM should have at Netflix. So things like configure dependency management, like resolution rules that I will talk about later. Publishing, make sure that you are publishing properly to certain repositories based on the status with proper metadata and such. Making sure that you can package your application for a specific operating system or runtime environment like Docker containers. Lint your projects by linting. Basically, how can we keep your build files updated with the latest opinions that we think are sane enough or that they are fine with the current version of Gradle that you're using. And things like dependency locking, making sure that if you go back in time, you are using the same binary dependencies. So that's the first part of Nebula. The second part is an internal distribution. By internal distribution, I mean, how can we go and say, we are going to roll out the new version of Gradle to everyone at Netflix? So I will talk a little bit about that later. So what I want to do next is talk about a little bit on our plugins, the Nebula plugins. So I'm going to do a few quick demos, or a few of them, probably 4 of them, and then tell how we use them, and then we will continue. So the first one is resolution rules. Resolution rules, I don't know if you are aware, but basically in Gradle, there is a really nice API that you can go and modify the resolution strategies. So basically you can go and say, you know what, Gradle, if you see the module A, I want to replace it with module B. Or if you see version 1 from this module, I want to upgrade it or downgrade it to version something. Or what about things like I want to exclude this in particular? And this is great. There are 2 problems that we see with this at the scale, which is one, you have the option to encapsulate all of this in a Gradle plugin, but basically you will have a plugin that will have strong opinions on dependencies. And when people start looking at the inside of why a dependency version was selected, they might not get all the context. They might not know that this is coming from a plugin or things like that. They might be confused at some point. And the second one is you cannot go and tell every single engineer, hey, you know what? We found that there is a bug on version 1.0 of this library. Can you add this code snippet so you can replace it? Or can you just go and modify this line? It might work with a small team, but it doesn't work when you are talking about hundreds of engineers. So for that, we created this plugin. And this Gradle plugin is also aiming to solve problems like, I have 2 artifact IDs where the group is different, but they have the same classes inside. Take example, the persistence API from Java. At some point, it was just Java persistence API, then JavaX, then Jakarta, but all of them have the classes under the same package, under the same group ID. So what will happen in the package is that if you load both artifacts into the class path, and for Gradle, that will be totally doable, because for Gradle, it's like, oh, you have 2 different coordinates. That's fine. There is no conflict resolution. I'm just going to add that to the class path. But what could happen is, based on the ordering, you might get one class or another, and it's not deterministic. It might change based on the environment that you're running. Who knows? So with these kind of rules, we try to avoid those problems. In addition, we want to make sure that if there are libraries that's supposed to work together and there is no alignment, we can align them for the user. Or also, if we see that there is a bug or a security vulnerability, we can bump or downgrade the version number for that particular library. So here are the links for the example that I will share in a bit, and also the links to GitHub. So you can go to the Nebula plugins org if you're interested about the plugins. But these are the links to this particular plugin, and also a link to rules that we provide open source for everyone. So let me just jump into my console and my IntelliJ app. All right. So in this project, I have multiple sub-projects. And I'm going to start with the resolution rules one, as I said. And let me open this on my IntelliJ. Okay. So the first thing is, as I said, the plugin ecosystem is vast, rich, and easy to use. So basically, you can just go and say, you know what, Gradle, I want to use this particular plugin on this particular version. And now you're applying this resolution rules plugin to your project. Easy enough, right? So 2 things that are important. One is resolution rules are created in a JSON format. And this JSON format is really useful for users because they don't need to understand the Gradle mechanics. They can just express the intention in the JSON file. And the way we distribute this is either via a local file in your project, which obviously is more like test purposes or something really specific to your project. And you can also publish all these rules to whatever you use in your company or open source, you use Artifactory, you use Sonatype, doesn't matter. You can just create a jar file or a zip file with all the JSON files, upload them to that repository, and then consume them just as another coordinate in Java. We provide an open source one that you can find on the links. So we have several rules that you can apply out of the box. So let me show you real quick how this JSON file looks like. So I'm going to showcase each one of these rules so you can get a sense of what this plugin really does for us. And then I will talk a little bit how we distribute this. So first one is the replacement rule. As I mentioned, Persistence API changed the group ID and the package name at some point, but the packages inside the artifact didn't change. So I am aware of that. As a build engineer, I know that this happened, and I shouldn't allow people to have both in the class path to avoid conflicts. So what I'm doing here is basically, hey, resolution rules, if you see this module in the graph, replace it with this one. So let me show you that. If I go back to my build file, I'm asking in particular for the new one, the Jakarta one, Jakarta Persistence API. And obviously, I'm not going to ask for the other one. That would be really such rare case where I need to do that. But the reality is that this usually happens in a transitive mode. Somebody else is bringing that for you. So I created a sample library here that brings the old one. So now let's say I'm going to run a dependency insight on this. If you are not familiar, dependency insight is a Gradle task that allows you to get more information about why a particular module and version were selected. So I can do dependency insight and pass the name. It can be with the group, without the group, partial name. Gradle will try to do the best to determine what's going on, but it might show you more results. So try to be as specific as you can. So now let's give it a few seconds here. So here's the interesting part. As you can see here, I have a JavaX Persistence API 2.0 that was brought transitively from my library, but it's getting replaced with Jakarta Persistence API 3.0.0. And the important part that we really like to surface to users, and that Gradle API provides this powerful feature, is that you can pass reasons for this. So we can say, you know what, this was selected by one of our rules, and this is the reason that we wrote for it. Because the Java Persistence API, JPA, was renamed to Jakarta at some point in time. So this is why we are replacing it for you. Let's go with another resolution rule. Maybe we found that Guava has a bug, or had a bug. Prior to version 30.1, this bug was creating some security vulnerability for all the company. So what do we do about it? Well, now we're going to say, you know what? If you see this module within this range of versions, I just want to replace it with a newer version. And here in my build file, I'm asking for an older version, 29. So let's see what happens now. I'm going to do dependency insight. This time I will use a shortcut. You can do abbreviations for the task names, and Gradle will detect for you. It will be okay as long as there are many tasks that could be matched to this. But in this case, I'm fine. I can do the I. And then you can see here that, okay, I'm getting substituted. I'm getting moved from 29 to 30.1. And yeah, of course, the reason I don't know why I want to use Guava, but I should use the latest. Okay, good for me. Let me show you the deny list, deny rule. Deny rule is really useful if you want to fail a build, if there is a dependency that you don't want to see at all in dependency graph. Let's take, like, you found that there is malicious code published under some particular coordinate, and you want to make sure that it's not in your dependency graph. There are multiple things that you can do here, of course. It's not only about the build side of things. You can deny this, add it to a deny list in your Artifactory or your Nexus, or so many other infrastructure that you can take action on. But it doesn't hurt to have a mechanism to prevent that in your build file. So now here, what I'm doing is, you know what, if you see this bouncy castle package that is not really from the official package, I just want to fail the build. So I will enable that so I can show that. and I will just run a Gradle build. And in this case, my build will fail right away because I'm seeing that there is this bouncy castle thing that is not supposed to be on the dependency graph. So you get the idea on what can you do if you find something that is really malicious. You can just create a rule and distribute this to the company and rest assured that all the builds will fail, but at least you won't have applications running malicious code. And the last one is the alignment rule. As I said, there are a group of dependencies that were released together that's supposed to be working together with the same version, but there is no guarantee that they will work together if they have different versions. So one example of this would be libraries to talk to the AWS SDK. You might have multiple modules like talking to S3, talking to SQS, you name it, any single service on AWS. So what happens under the hood is that you might be using SQS, let's say 1.x, and then somebody decides to bring 2.x transitively for somewhere like S3 or Dynamo. And all these libraries usually rely on core libraries. So now you are bumping the core for all the dependencies, but you are also using the old one for the SQS. So let me show how this works. So basically here I'm saying, you know what, if you see all the dependencies on this group, com.amazon AWS, and it includes in the module name things like AWS Java SDK, or is a prefix for that, just go and align them. So here, I'm just going to do it directly. I'm asking for S3 with version 931, and I'm asking for SQS version 946. So let me run a dependency inside on the S3 one, which is the low one. Okay, so now this is interesting. Now you can see that it got upgraded to 946. But why? Well, there is a rule that says that they should be aligned. They work together. So basically, it will go and align to the highest because that's the Gradle default behavior, unless you have a stronger opinion, like you require or have something that you need to be strict about it. One thing that is really important here is these kind of libraries like Amazon, AWS, Jackson, Databine, JUnit, and so they produce something called a BOM file. And a BOM file is basically a BOM file that contains a series of dependencies with versions that they know they work together pretty well. And then with Gradle, you can apply that BOM file, and it will instruct to use those versions from the file. So you can use a BOM. The problem with that we have internally when it comes to BOMs is that not everyone is producing BOMs. It might be a difficult thing to do. You cannot ask everyone to produce a BOM and consume a BOM. And now you also need to make sure that you do proper conflict resolution of dependencies where there are many BOMs involved. All right. So as I mentioned during the metadata problems, it is quite common to have bad metadata. So one of the things we do, and this is also an open source plugin, is we provide same defaults for publishing to Maven and Ivy. You can basically go and apply the Nebula Maven publish, and you will get a Nebula publication under the hood that will configure the jar task properly, that will configure that you use result versions with publishing. And if you combine it with our other plugin called Nebula Info, it's going to collect all the information from the environment, which you can look on the left side. Basically, you can get information for like where this thing was built, what was the version of Gradle that was used, and so on. So let me just show that real quick. So I will go to my example. It's called release example. I'm just going to open this. By the way, all these examples have also a README with all the steps that I'm following right now, so you can reproduce that in your machine at some point if you want to. So let me show you here, as I said, just applying Nebula, Maven publish, that's enough. And what I want to show here is what are the things that should be on my POM file. So I'm asking for Jackson Databine 2.x, and the very interesting part is that I'm asking for Guava latest release. This matches to the one that I was referring in the pain points. So now I created a task that allows me to publish. I'll publish this Maven. And what it will do is publish this distribution just inside my build folder. Nothing interesting. But I want to show the POM file. So the important things about the POM file is, okay, we are translating those ranges or dynamic dependencies into real versions. We are not adding ranges here that will prevent from reproducible builds in the future. We are basically saying, okay, you asked for 2.x, I resolved 2.12.2. Similarly to Wawa, you asked for latest release, I resolved 30.1-GRE. So this is great for us. It is also important to know that in Gradle, I truly believe that you don't get what you see is what you don't get. You might be asking for 2.x, and it is possible that you will get that. But it's also possible that a transitive will bump you, and it is also possible that some other plugin will have an opinion. So it is really important for us to know what was asked and also what was resolved at the very end. And then the metadata that really help us every single day internally is to understand where these libraries or applications were produced. For example, here I know that it was produced in my machine, that is using a particular operating system. When was this created? What was the Gradle version that was used? Information about the Git repository, the commit, because I want to understand what commit was built in case that I need to trace back from my Artifactory or whatever other service that you might be using. And also things like, okay, what was the Java version that I was using for target and compiling versus the version that was used to run this build. And if you were running on a CI environment, you will get things like, what was my Jenkins job? Either my Jenkins job or my Travis job, my Run CI job, Circle CI. We have supported the plugin for multiple CI providers that are out there, or the more popular ones. Right. Linting. So linting is really powerful tool, and this is built in order to help us reduce the tech debt when it comes to build files. Basically, we can say write rules that will replace patterns or replace particular method usage, API usages from Gradle or other plugins, and replace them with proper or new opinions. So let me show this. So before I go to the running the commands, I just want to show here that I'm applying the Nebula lint plugin. And what this plugin does is you can either have rules written in your build source, or you can also distribute them as a jar file. You can have all the rules in a jar and distribute that to your company. The most important thing here is that you implement your rule in Groovy. We have a class called Gradle lint rule. And this Gradle lint rule allows you to basically hook into multiple parts of the build process. You can hook into things like when we are visiting a sub-project block or the project's block, if we are visiting any dependency, or if we are applying a plugin with the plugins block or directly with apply from, we can react to that and look at the method call or the expressions and make sure that we are not using a bad pattern and then replace it if necessary. So when you write a rule like this one, you also add a properties file under this folder structure. And as long as your jar contains these classes with the proper properties file, they will be available for you to use in lint. So here I have two rules. One is JSON cleanup. I will get into that. Strong feelings. And then shadow plugin minimum version. With the shadow plugin minimum version, what I want to do is basically, I want to make sure that I'm using the latest. So I'm just going to upgrade people when I see an older version. And with JSON cleanup, the one that is, I would say the simple one to implement here is replacing JSON with Maven Central. If you are not aware, Bintray and JSON are basically getting sunset by JFrog. By the end of this month, you won't be able to publish to either one of those. By the end of May, Bintray will disappear. It won't be accessible anymore, and your files will be deleted. So please, if you are a library author and you maintain a package on Bintray, move it to Maven Central so you don't break the bills in multiple companies. And then JSON is going away next year. So it will go into a read-only mode at the end of March, sorry, and then it will disappear on February 2022. it is what it is. I think it's a great move for the ecosystem at the end, but it comes with multiple pains that involves its migration. So going back to this, basically you can go and say, you know what? If you see JSONer method, because in Gradle you can just go and use JSONer, Google, and Maven Central in order to declare these particular popular repositories. I just want to make sure that I'm adding a built-in violation, and by this I'm just going to create a warning for the user, but also I have the ability to replace it with some particular code. So in this case, I'm just going to replace it with Maven Central. So let me show you how that works. So in my project, I have a task called link Gradle. Here we get some warnings. My build will fail. Basically, it will say, you know what, you are using an old version of Shadow plugin, and also you are using JSONer. My build, it's able to succeed if I just run the build task. That's fine. I'm just going to get the warnings. It is also important that you can have critical rules. If I enable the critical rules for these particular rules, my build should fail. Okay, so now I have the warnings for also fail my build. But we also provide a fixed link Gradle task. And this fixed link Gradle task, it's going to basically go and apply new opinions that we can write with the rules. If I go back here, you will see that I'm not using JSONer, and I'm upgrading to the latest Shadow plugin. So what we do with this is that we distribute several rules across Netflix, and every night we open PRs to the projects that are subscribed to get these updates, and we start moving them to new versions of the opinions or new versions of the plugins, or removing things that shouldn't be there. Like, for example, we provide internally repositories that mirror Maven Central and the plugin portal. So we write rules that remove these lines of code because it's really craft, so we don't need it. Also things like that. Dependency locking is another one that I wanted to showcase real quick. At some point, we had our own Nebula dependency locking, but we had the opportunity to work with Gradle team in order to have dependency locking as part of Gradle itself. They did a phenomenal job on getting this feature in. And now, if you're using dynamic dependencies, or just you want to make sure that you are always having the same versions every time you build the same commit, you can use dependency locking. So let me show you how that looks.
One question, Roberto. You say that you push a PR to update that linter library.
Yep.
To whoever, whatever project gets subscribed. How do you guys handle that subscription to?
Yeah, I will get into that later, but it's not really part of the plugin itself. It's another part of infrastructure that we have internally at Netflix.
Gotcha.
Thanks. Yeah, I'll get into that just a few minutes from there.
Cool.
Yeah, thanks. So let me show you the dependency locking feature. Here what I'm doing is, as I said, there are POM files. Here I'm applying the Jackson POM via platform Gradle, and I'm asking for a particular version, 2.9.8, and then my dependencies don't have a version. They will get resolved based on whatever is on this file. So let me show you. Here, with this feature, you can pass the flag write logs when you are resolving dependencies. And what Gradle will do is basically the same. It will resolve the versions, it will show you the output of all of that, but also it will create these files inside a dependency logs folder. And here, if you go, for example, to the compile class path, you will see that it resolved Jackson core, Jackson databind to a particular version. What is important about this is that imagine that I decide to just go and modify this. I want to use a newer version, but I forget to create the new log files. The next time I go and try to build my project, it's just going to fail. And Gradle is going to tell me, you know what? You have a version that you're asking for, but also you have a different version in your log files. Go and decide what to do. Basically, you can either update the log files, or you can downgrade in your build file. So this is very useful when you are doing things like latest release. So you always build against the same version over time, unless you regenerate the log files. So this is how we leverage the dynamic approach for dependencies at Netflix. All right, this is cool, right? But what about distributing Nebula? So I have talked about multiple plugins, either open source or internal, But we cannot go and ask every single engineer to apply all those plugins themselves and then add tech dev in order if we can upgrade them later. So this is when the custom distribution come in place. Custom distribution, I don't think there is like an official guide in the Gradle docs, but it is something that is people are aware of. And basically is wrapping Gradle in your own zip file with custom things that you want to do. For example, I want to have custom in scripts. I want to configure repositories for people. I want to enable metrics collection. I want to provide default behavior in my Gradle properties file, like how much memory I want to use, or I want to apply internal or specific OSS plugins for them. So let me showcase this real quick. So building a custom distribution is not that complex. It really the complexity comes with how do you test it across all the repos that are using them. We will get into that. But basically, when you're building a custom distribution, the way we do it is we download the Gradle distribution based on what we have in our Gradle wrapper properties. So right now we are using 6.8.3, the latest. And we download those files, we extract them into the build folder. And then what we do is we recreate a zip file with everything there that was in the original one. And we introduce the things that we want to configure. So in Gradle, if in the distribution, if you have an init folder with init scripts, it will execute those out of the box for you. And then if you add Gradle properties under the defaults folder, it will use those properties on every single build. And the only change we do is basically naming and versioning. We name this my company Gradle distribution. For us, it will be Nebula. For you, it will be something that makes sense for your company. I don't know, my super duper build tool. And then what we do when we run something like Gradle build, it will download the Gradle distribution, it will do the extraction and such, and it will create a zip file like this one. Now, what I want to show is what are the things that I have in there. So I said init scripts. I have something really simple. Basically, it's something that we print a message that says that I'm using a custom Gradle distribution for your company. And the second one is adding some dependencies to the build script class path, because these are plugins that I might or might not apply, but I want to provide them for free to my users. And the second one is the default properties. I want to make sure that the Gradle daemon always runs with maximum 2 gigs. So let's see how that looks. So for that, inside this folder, I have a sample project. And here in my sample project, I can do Gradle build environment. That was fast. So what you can see, well, let me jump real quick back here. So the sample project is nothing like an empty build file. It doesn't have anything at all. It doesn't apply a plugin, nothing. It's using my wrapper. I'm pointing to a local wrapper that is the one that I just created, my company Gradle distribution 1.0.0. And here, what you can see is that I'm printing the custom message that I created, and also I'm seeing dependencies on my build script class path, which means that my init script is getting executed with this custom distribution. So here you can do things like configure repositories, configure the plugin management block. Everything that you can think of about settings or applying same defaults could happen here. So now another thing that I want to do is show you my Gradle daemon process. So I will let this thing run again. Just look at my process in Java. And here it is. I have a Gradle daemon using 6.8.3, and it's using my flag that I added to my default properties, 2 gigs. So this is how you can take, not control, but provide defaults to your users via a custom distribution. All right. So how do we validate new versions of Nebula? Unfortunately, this is not open source, but we have something called Niagara. And Niagara is a project that allows us to basically say, hey, Niagara, give me all the repositories of Netflix that are using Nebula and run them against this particular Nebula version. And the new version can have either a new Gradle version, a candidate release from Gradle, an idle release, or a new feature that we're building internally for our teams. So what Nayara will do is basically go and clone those 3,000 repositories, each one of them on its own Docker container, and execute them in our orchestration platform, Titus. And then once those builds are finished, it will give us back the feedback on what happened with every single one of those builds. So that looks like this. It's a Jenkins job that will show us things like, you know what, more than 2,000 succeeded. There are around 52 that failed during the configuration phase. You have 33 projects with compile issues. 59 of them will have to address the link because they have bad opinions. And we also have a failure analysis that allows us to know the messaging. Like we parse a message and get the proper information like, oh, you know what, you're using generic log task, which is not supported with a new feature from Gradle for logging files. Or you're using something called logback config that doesn't exist anymore. Or you try to run this thing with JDK8 when it's supposed to be running JDK11 per opinions. So we get the feedback from these 3,000 repos, and then we take decisions based on, does it look good? Does it make sense? Are these real issues because the projects are not in good shape or because they are kind of abandoned, maybe? Who knows? So after that, we decide if we roll out a new version or not. And here comes probably the answer to the question about enrollments. How do we upgrade projects? So one of our teams, the continuous integration team, created something called Rocket. And Rocket CI is basically an abstraction on top of Jenkins that allow us to have better control, automatic control on things like how we manage the source code for engineers. If you're interested to know about Rocket, there is a link to this talk from Elise McCallum. She works on that team. This is a great talk from QCon, probably from 2 years ago, 2019. She talks about how they are evolving the continuous integration story at Netflix with this tool. But going back to this, they provide for us something called managed source, which allows us to subscribe projects to automatic pull request. Basically, when you create a new project at Netflix using our project generation tool, you will enroll into Rocket for 3 things. One is dependency logs, Nebula wrapper, and lint rules. So every night, and this is configurable, every night you will go and get a pull request if there are new lint rules that should apply to your build, or if there are changes on dependency logs. You can see the dependency logs similar to what Dependabot or things like that will do for you. But this is our internal tool for that. And the next one is Nebula wrapper. When we release a new Nebula version, it will go and open pull request to upgrade the wrapper properties with the new version. Today, we have probably 1,400 out of 3,000 repos that are enrolled into Nebula wrapper. So once we release Nebula, a good chunk of all the fleet will get that in a few hours. So by the end of the day, when we release a new version of Nebula, almost 50% of the company using Nebula will get the latest version of Nebula. So we are always working for more adoption of these tools. Going to faster builds. So we don't do anything specific that we have built other than using Gradle features. Build cache is heavy, something that we have introduced. If you're not familiar with build cache, basically you can cache the inputs and outputs from tasks and the transformations of your artifacts. And if you have Gradle Enterprise, you can push this cache to remote agents, remote nodes, and this can be reused by the engineers in your company. Another nice feature that came out probably 4 minor versions ago is the read-only dependency cache. You can share that now. So what we do, and I have an example that I link in the next slide, is that you can go and create a zip file that contains, you can create a folder that contains the metadata and the jar files with the POM or IB files of the dependencies that you usually use and distribute that to your company. We adopted Gradle Enterprise, so we have access to build scans. We use build scans heavily now. It helps a lot to understand more about what are the performance bottlenecks, what are the opportunities in your build, like flags that you're missing, and the next one is important, parallel execution, as I mentioned before. Share dependency cache, I want to be cognizant with the time, so I just leave the link to that. Basically, you can take the modules to folder from your Gradle home caches and copy over some information into some share infrastructure. For example, if you are running in Docker your CI things, you can mount that as part of your container, or you can have it in your Jenkins agents as we do, and then reference that in Gradle via an environment variable, which is on the right, and Gradle raw depth cache. And what Gradle will do is read from that cache instead of doing the network tree. And you can verify this using the build scans that you can see on the network tab that you are not requesting these dependencies. So I have an example for that. Feel free to reach out if you want to know more details about it. With Gradle Enterprise, we don't do a lot of work. One of my colleagues did a fantastic work on setting up this instance and also provide custom values and custom tags so we can filter things by that. So for example, we are able to know information like the commit or the Jenkins job, the Jenkins stack, so we can search for particular builds on a given Jenkins job name instead of just the module name, for example, or the project name. Similarly, for tags, we can do things like, oh, this was wrong on CI, this was wrong with Nebula, or this was wrong in Jenkins or in Titus or in a Linux or a Windows machine. So then we can search for those tags. For example, if we were having issues with all the Windows builds, it will be easier to look at the tags for Windows and then understand why it's only failing there. And did someone say visibility? I mentioned something about visibility. We have another tool called Astrid. This is not open source, unfortunately. Basically, what Astrid does is index information of the dependency graph and then provide that for engineers so they can understand how the libraries are getting used. So when we push a new jar coming out of Nebula, we provide a manifest with the information of all the dependencies that were used, and Astrid will take that and index it on its side. And then this helps to understand more the change around the Netflix ecosystem. And it's really useful for deprecations and security vulnerabilities. So when you are an engineer at Netflix, a JVM engineer, you can go and search for a particular module on a Spinnaker. Spinnaker is our continuous delivery tool. So you can go and search for a module, and you will see all the versions there, and then you can see the adoption of one in particular. And we can show you how many server groups and the percentage of the adoption of that particular version. For example, here we have Baba 19 that it's being used by 1,300, almost 1,400 server groups, which is 25% of adoption. So now, as an engineer that owns a library, can understand who is using it and then take decisions. However, we are not there yet in the part of how are they using it. We don't know the details about the API yet. So when you own a library, you can create campaigns. Basically, you can say, you know what, I don't want you to use Baba 19. I can create a campaign that could be critical or not critical. Non-critical, we will show you just warnings in Spinnaker for your application or in your build file, in your build output. And if it is critical, we are going to fail your build because you shouldn't be using that. Also, when you create a campaign, we try to provide you all the context, how many server groups, how many artifacts, applications, things you are going to impact if you create this. So one of the important things about the culture at Netflix is the freedom and responsibility. So we give engineers the freedom to take this decision, but also they are responsible for making sure that they are not going to break the whole ecosystem. So what's next for us? There are 4 major features from Gradle that we are excited about. First one is distributed testing. If you have Gradle Enterprise, you can go and start your own agents, basically, where you can leverage testing. Think about in a way that you will do remote testing. Basically, you will have your build, and you can configure the agents with particular capabilities. Like you might have agents running in Linux, agents running in Windows, or having a particular database or a particular set of tools. And then in your build file, you will ask for those capabilities, and Gradle will look for those particular agents and schedule the work there. So now you are not using the compute resources from your local machine or from your CI infrastructure. You are using the resources from the agent, and those tests are getting run isolated, most likely. Java toolchains, something that is out of the box with Gradle right now is that the JDK you use to run your build is the one that you use to build your project. And you can have opinions on which version to make that compatible via the release option or via things like source compatibility, target compatibility, or in reality, they should probably be split, right? You can run with JDK 11, but you probably want to compile with JDK 8 properly. So with toolchains, you can do that. You can basically express that opinion. You can say, you know what, for this project, I'm using Java 8, or I'm using Java 11, or whatever you name it. And Gradle will be responsible for looking for that particular JDK in your local machine. It could be Java Home, it could be SDK Man, or they support like 4 or 5 package managers. And then it will run the tasks like compilation, Javadoc, and all of those with this particular version. It is important to note that the full support is for Java and Groovy. So if you are using Scala, you might have to wait for a bit. Hopefully, people at Gradle will get into that soon. But this is a great tool. Actually, Cedric, I'm terrible with last name, Shampoo, published a blog post today about how to use Java toolchains. So if you have a chance, look for that. It's really, really interesting. Gradle metadata adoption, something that we want to do. Gradle metadata was introduced in Gradle 5.6 as a feature preview, enabled in Gradle 6. And basically what you can do with that is enrich the metadata that you provide to your consumers. So instead of a POM file, you will create a .module file. And this module file will have things like, if you have constraints to say, I wanted this strictly or I wanted this required, those opinions will translate to the module file. Today in your project, if you say, I want to force Guava to 19, the POM file only has 19 at the end. And it doesn't know and the consumer doesn't know why you selected that. With Gradle metadata, you can take it far and you can say, you know what, I'm using 19 because I require this. I strictly need this. And then Gradle will take a better decision and try to resolve conflicts based on that. And lastly, configuration cache. Configuration phase could be expensive in very large repos, very large projects with multi-module projects. So similarly to build cache, configuration cache is not out. It's still on early stages. There are many plugins that need to adapt to this in order to not create tasks eagerly, in order to modify the dependency graph during configuration phase and so on. But configuration cache for us is a game changer. So definitely give it a try if you have the chance. With that, that will be it. Thank you very much. If you have any questions, happy to answer them now. If you want to reach out, again, here's my email, Twitter, my GitHub account. I'm always happy to chat with people, meet new people, and yeah.
Cool. Thank you, Roberto. Any questions, please send them over on the live chat and we can pass them over to Roberto. On the meantime, just want to plug again our new project. If you want to join the Devs Office Hours, we haven't had our first event, but I mean, you can join and we'll let you know if you want to have an opportunity to mentor or to learn from others. This is the place, an informal place for anyone at any level. Okay, so let me see.
So I had a question, Roberto. So I know that, I mean, you show a few plugins, and so I don't know if you have seen other companies adopting the plugins that you were showing us, but so what would be probably the best way to adopt things like the resolution rules plugin? Is that implemented at the team level, department level, organization level? I'm not sure if you have any insights about that.
Yeah, so for example, prior to Netflix, I used resolution rules on my previous job just for the team level because we wanted to align some dependencies. So it really comes to how much leverage you want to have. If you have the buy-in from the whole org, well, it makes sense. It really comes to, do you have a centralized build team? Do you have a team that takes care of opinions around which versions are good or bad, or that have opinions on the frameworks? Then it makes sense to do it at our level, in my opinion. But that doesn't stop you from doing it like a department on team level. If you know that there are cases where you might have a multi-repo approach, then it makes sense to do it. Obviously, a mono-repo is not necessary. Why would you do that? Just change opinions within the same project, and that's pretty much it. So yeah, I would say that even for team repo makes sense if you have, I would say, a good size ecosystem when you have multiple projects and you know that you might be hurt by any particular dependency. it's not that complex to automate, to be honest. The other important part is if you use dependency locking, when you use resolution rules, you are also locking the resolution rules version. So the builds are deterministic. So you can go back in time and build against the same opinions. So you won't get like caught by surprise because something changed in the rules overnight.
Yeah, that makes sense.
And yeah, there are a few companies out there using. We get some resolution rules issues every once in then. Probably, yeah. I don't have anyone to call out from the company perspective, but there are a few users that are usually looking into resolution rules issues.
No, I found that like very powerful. I mean, it should be very useful for companies to adopt those type of rules, because you can actually help development teams to, or stop development teams from facing several issues that are related to dependency. So yeah, that was awesome.
Thanks. I think the important part also is that we don't do any magic trick. It's basically just providing an abstraction on top of what Gradle provides for you. It's just trying to make it easier for engineers to. What we do internally is that we allow engineers to contribute to them, so they will just go and open a pull request with a JSON file. They know their library, right? If they create a bug or something, they know that what should change. So they just go and open a pull request with a proper test, and that's pretty much it. Instead of leveraging the changes at the Gradle API level for everyone. So
yeah,
that's what makes it easier too.
Yep. Yeah, by the way, Orlando put the banner for the raffle, so we're gonna have a raffle in a few minutes. Orlando, you have any questions? I don't see any questions in the YouTube stream channel.
Yeah, no, but I have a question. I just lost my train of thought. I'm focusing on too many things here. But yeah, never mind. Totally blanked out.
All right.
Yes, now I remember. Sorry. So the lint rules, the linter rules. So whenever you have a big rule, like we're going to deprecate a certain jar version or something, what is the process and who's involved in taking those decisions?
Lint rules are more for like modifying build files. I don't know if that's what you meant, but we own the process because we have a centralized team that tries to provide all these ergonomics and opinions for every single engineer. So we are trying to keep up to date with all the new Gradle features, for example. So there will be things like you shouldn't be using these particular properties from a particular plugin. So what we do is create the rules ourselves, and we do acceptance testing for that. So we don't ask people to to create rules for their teams. That's basically something that we really own and we create for them.
Is there any instances that so let's say I'm subscribing to those to the linter, right, and I get this PR, but that's breaking my build, and right now, well, I need to keep going and releasing features. But if I merge your PR, that might block me, and it might or not be a big change, right, internally.
Yeah. So there are two things here. One is one implementation detail is that prior to open the PR, we make sure under the hood that we can at least do a quick checks, that you can at least, for example, run the assemble task, I think it is. Basically, we make sure that you can apply the plugins, that you can run a simple task like build environment. So that's the first check. We don't even open a PR if that fails, so the user doesn't get anything. The next step is that the contract is we open a PR and you can decide to auto merge or not. But in reality, the contract is that if you have proper tests or whatever. So if your PR is green, we are going to auto merge for you if you are okay with it. Obviously, we will be responsible for a breaking change, but we try to encourage you to have proper test coverage in case we are changing something. I don't know, test framework opinions, for example. But yeah, there are many opportunities out there. For example, something that we don't do today, and there is we have talked to our companies about it, is ways to validate that breaking changes in publications, for example. What if I'm introducing a new version of Gradle that modifies the way a POM is generated? That's really difficult to catch because probably in the PR you're not even building something. So we will have to write some tooling aside that verifies some particular projects to make sure that you are not probably dropping dependencies, things like that. So yeah, it's always coming with a risk, but we try to minimize the risk with acceptance testing. There will always be instances where, yeah, we merge a PR and now something is kind of broken on my build and we need to react right away.
Cool. We have a question on the chat. Let me put it there. Do you get to see that, Roberto?
Yeah.
Question from Steven Cregan.
I would like to know more about what is an indie team. If you can tell me, folks.
I would say that I think he refers to a small team, like probably startup kind of setup. So yeah, that's what I would think.
Yeah, so you talk a lot about enterprise type of problems because of volume. I think a lot of these problems is because of that, right? If I build a library and I have two teams, I can maybe slack them, right? And I have a new version. But if I have 1,000 services using it, that's a different story.
Yeah. So there are cases where these plugins don't really fit into those kind of things, to be honest. At some point, it feels like over-engineering the problem because, if you have two projects, what's the point of applying certain things? The reality is that there are core features like dependency locking that I will definitely use every single time, regardless if you have automatic updates or not, just for the sake of having reproducible builds. So that's irrelevant. That's not related to the scale, right? So reproducible builds are important. Other thing that I will say is you probably don't have the ability to build a lot of infrastructure where you can rely on existing tools. For example, if you have a few projects, you might leverage things like Dependabot, right? It comes with good things and bad things. I don't think it's really great for Gradle in some cases, like upgrading plugins. It's not even, I think it's possible for a few cases now. And then you need to tweak it properly, but probably you can leverage things like that. You can even leverage things like Sneak, I think it's pronounced Sneak. So those are existing tools that you as a small team can leverage and don't build yourself. So you can get things like dependency locking every once in a while. You can also go and get security vulnerabilities, pull requests. So those are things that I will say that probably for small teams make sense because you don't have a centralized team that is going to provide opinions for you. And the other thing that I have seen also is if you start detecting that your projects are growing, like the number of projects, definitely abstract away things into plugins. If you start adding the same opinions every single time on different projects in your Gradle build files, that's a perfect opportunity to create a plugin that provides that for you, and then you can leverage that automatically for every single project that you own. For example, if you have 10 or 15 projects, then it might make sense to have a plugin that configures repositories. Things like migrating from JSON could be easier if you had something like that. So the plugin ecosystem is a good friend when it comes to start reusing build logic across projects, regardless of how many you have.
So, and that actually made me think about the question. So, do you know about any plugins that, for example, if you are you're using Sneak in this place for security scanning, and you find that the dependency has a security problem, is there a plugin that actually helps you, like adding those rules into the rules dependency, the rules resolution thing, or that's something that you guys do manually?
We don't do it internally. We have a security team that basically prioritize these vulnerabilities. The reality is there are hundreds or thousands of vulnerabilities every single day, right? Yep. And if you start opening pull requests for each one of them, it's just insane, right? Like if you're an engineer and you get like 30 pull requests a day because dependencies should be changed, then something is wrong. That's not the kind of feedback you want to get. So this team in particular is responsible for provide the campaigns internally, and then they create resolution rules for that. It's still a manual process. That's something that we want to automate in the future. They are working in some early stages of automation. And also one of the things that they would like to do at some point is only create a resolution rule or only open a pull request if you are exercising the vulnerability. So there might be something in some particular method that you don't even use. You are not going to go through the hassle of upgrading thousands of repositories if nobody's using that. But you really just want to upgrade the 5 or 6, whatever number, that are facing that issue or potentially facing the issue. So that's on the works, I guess. Outside of Netflix, I will say that I think now, for example, with GitHub, I don't know if GitHub Enterprise, but GitHub itself, you can now make a sneak open pull request against your project via Dependabot. So you are covered on that side. So if a sneak detects something in Jackson, it will talk to Dependabot and open a pull request with that version that shouldn't be used and upgrade you or downgrade you, whatever.
Yeah, that's a cool feature.
It's always Jackson, right?
Yeah, Jackson, like Databind is the one.
Those are my examples. Jackson, Databind, and Guava. Guava is like a pain point.
All right.
Cool.
I don't have any other questions, Orlando. Do you have any?
Nope. I think it's Roberto's turn to make a question. So we're gonna raffle one license for a single JetBrains product of your choice. And the first one that answers Roberto's question, which is a question related to the presentation, will get the license.
And something that is worth mentioning, guys, is if you're the winners, try to get the license or just use the coupon as you get it, because they expire. They have an expiration date. If you don't use it by the time that it expires, it's gone. So try to use it as soon as you get it, so you can get the benefit.
Yeah, or you can, I mean, this is transferable. If you feel like, yeah, I already have a license, but this license can help another developer that doesn't have the opportunity to use one of these tools, send it over to them. I mean, it's a good thing. There are a lot of people that cannot afford outside maybe a license, or even in their job, they don't get to use any JetBrains tool. So,
all right,
yeah.
Roberto.
Yeah, let's do since we have been talking about this after the questions, like what would be a good use case for resolution rules? When would you use resolution rules?
Good question.
The wait time boxes for like 5 minutes.
Yeah, the YouTube stream has a few seconds delay, so we'll just wait for an answer. And if we don't get an answer, we ask another simpler question. But I think this one is pretty easy.
the question was, what is a good use case for resolution rules?
Prior to the recording, we were joking about asking for my name, like Mexican teachers will do. But then I realized that our names appear in the screen, so it will be easier.
Yeah.
There's an answer in the chat, Orlando, if you can post it.
Okay, so the first one that got in from iHor, aligning multi-module dependencies versions.
Yeah.
Cool.
Also, we have a winner.
Congrats. You can send us an email to that email that I'm putting on the screen, info@cltjoc.org, and we'll send you your coupon for a 1-year license.
All right. Well, we don't have any other questions, so I think we're good to wrap up this event. So, any final words, Orlando?
Nope. Just again, plugging in the Devs office hours. A good place to share knowledge and to learn from others. But that's it. Thanks everyone for attending. Thanks again for our friends from the virtual jog, and hope to see you. Well, and
And
thanks a lot, Roberto. Yeah, it was really good talk. And well, hope to have the opportunity for you to give another talk, maybe in person, sometime next year. And thanks everyone for attending.
Thank you,
See you on
guys.
the next one.